Hello friends, my name is Devendra Datsak and today we see the PPT on three-phase induction motors. First we see that what is an electric motor. An electric motor is an electrical machine that converts electrical energy into the mechanical energy. Electric motors can be powered by direct current source such as from batteries, motors, vehicles or rectifiers, or by alternating current source such as a power grid, inverters and electric generators. Then we see the how does the induction electric motor works. An electric motor is an electrical machine that converts electrical energy into mechanical energy. Most electric motors operate through the interaction between motors and magnetic field and electric current in a wire winding to generate force in the form of torque applied on this motor shaft. In this diagram, the how does the electric motor works is this explained. Then we see the types of motor loads. Constant torque loads. Output power varies, but torque is constant. For example, conveyors, rotary keels, constant displacements, and pumps, and etc. Second types of motor load is a variable torque load. Torque varies with the square of operation speed. For example, centrifugal pumps, fans, and etc. Third type of motor load is a constant power loads. Torque changes inversely with the speed. For example, machine and stools. Then we see the types of electric motor. First type of electric motor is alternating current. In alternating current, two types of motors are divided. First is synchronous motor, and second is induction motor. And single phase motor and three phase motor. Second type of electric motor is direct current motor. In this indirect current methods, two types are derived. Separately excited motors, self excited, series motor, compound motor, and shunt motor. Assessment of electric motors, efficiency of electric motor. Then we see the factors that influence the efficiency of motor: age of motor, capacity, speed, type, temperature, rewinding, and last one is load. Construction of three-phase induction motor. The electric motor construction can be done using the rotor, bearing, stator, air gap, windings, commutator, and etc. The rotor is an electric motor is the moving part. The main function of this is the rotor shaft for generating the mechanical power. In this diagram, it is the diagram of construction and major parts of a three-phase induction motor. Then we see the AC motors. An AC motor is an electric motor driven by an alternating current, that is AC current. The AC motor commonly consists of two basic parts: an outside stator having coil supplied with alternating current to produce a rotating magnetic field, and an inside rotor attached to the output shaft, producing a second rotating magnetic field. This is a parts of AC motor: stator, rotor, bearing, windings, cooling fan, frame, terminal box, eye bolt, and etc. This is a part of AC motor. Most common motors used in industries. Advantages of AC motors: simple in design, inexpensive, high power to weight ratio, easy to maintain, direct connection to the AC power source, and AC induction motor. Then we see the how does the induction motor works. Electricity supply. First, electricity is supplied to the stator. Magnetic field generated that move around the rotor. Current induced in the rotor. Rotor produces a second magnetic field that opposes the stator magnetic field. Rotor being and then rotor start being to rotates. Important parts of induction motors. First part of induction motor is stator. Stator, it is the outermost stationary part made from a silicon steel stampings. It is used to house the three-phase stator windings in these slots. The slots are constructed on the inner periphery of stator surface. Second part of induction motor is a rotor. It is the cylindrical body made from a silicon steel strappings. It is put on the shaft. Hence, rotor is rotating part. It consists of thin rotor copper bus bars put in the rotor slots called rotor conductors. All the conductors are sorted by end rings. In this diagram, rotor and stator are denoted. Then we see the synchronous speed of AC motor. The speed at which the magnetic flux rotates around the stator or through the air gap is called as synchronous speed. The synchronous speed measured in a RPM, that is rotation per minute. It is denoted by ns. Then we see the rotor speed. The speed at which the rotor actually start rotating is called a rotor speed, and rotor speed is denoted by the NR. Then we see the slip speed or relative speed. Slip speed is also known as relative speed. It is the difference between synchronous speed and rotor speed that is given by ns minus nr. Working principle of AC working principle of motor. When three-phase stator winding is fed by the three-phase AC supply, a magnetic flux of constant magnitude but rotating at synchronous speed is developed in the stator. The rotating magnetic flux is cut by the stationary rotor conductors. According to Faraday's law of electromagnetic induction, EMF is induced in the rotor conductors. As the rotor conductors are shorted by the end rings, a current will start flowing through rotor conductors. The frequency of rotor EMF is equal to the supply frequency. This is a power flow diagram of motor. Working of power flow diagram. When input power is given to the stator, current starts flowing through it. Due to the stator current, iron loss and copper loss take place in it. After deduction of these losses, remaining power is given to the rotor. Due to the rotor carries current, copper loss take place in it. But due to very small frequency, rotor current, iron loss is very small. Hence, it can be neglected. Remaining power in a rotor utilized to rotate the rotor, that is mechanical power developed in a rotor, that is PM. Frequency at starting and running condition. Frequency at start F is equal to Sakala frequency. Frequency under running condition is given by Fr is equal to S into F. Induced EMF at starting and running condition. EMF at start E is equal to low. EMF at running ER is equal to S into E2. Torque slip characteristics of three-phase induction motor. This is a torque slip characteristics of a three-phase induction motor. Thank you.